Lesson 7.1 is about adding, subtracting, and classifying polynomials. I'm going to approach this video a little bit different since I won't be in class for this lesson. I'm going to show you the answers for everything, including the try problems, but I'll tell you before I display them because I'd like you to try them before I do them for you. So let's get started. First vocabulary term is monomial. A monomial is a number, variable, or the product of a number and one or more variables with whole number exponents. That means non-negative, non-decimal numbers. So 0, 1, 2, 3, no negatives though. You probably won't see a 0 exponent, but hey, it's a possibility. All right, so another name for a monomial, this isn't an exact synonym, but one individual term. All right, now terms don't have this rule where they have to have whole number exponents, but this is a good way to think about it, is one monomial is like one term in an expression. So an example of a monomial would be something like 2x squared. That is a monomial. It is one term. It can be a number, variable, or the product, which ours is, of a number and one or more variables. It's the product of 2 and x squared. Okay, what's something that's one term that would not actually be a monomial? A term could be something like 2 divided by x. That would still be a term, but that would not be a monomial, because x in the denominator can be written as 2 times x to the negative first power. Well, -1 is not a whole number. -1 is an integer, but whole numbers have to be 0 or bigger. Whole numbers are not negative. Integers can be negative, but whole numbers very specifically are non-negative integers. Okay, so monomial. Here's one rule where it's broken. No variables in the denominator, no negative exponents. Here's an example that does work. Can have a variable, but it has to have a whole number exponent. Next vocab term, first thing we use to classify a polynomial is its degree. So the degree of any single monomial is the degree being the sum of the powers. All right, so I'll give you a little chart in a second, but I can have multiple variables. So I can have x to the first power, or just x, and then y squared. The degree of this term would be 3, because I do the sum. Gosh, my marker's dying here. I do the sum of the powers. So 1 plus 2 is degree of 3. So this is what degree means for a monomial. Here's a table that you have in your notes. I'll just talk through the results. So remember, the degree is the sum of the powers of the variables. In this monomial, I have no variable. So if there's nothing to add together, the degree is going to be 0. In 3x, we do have a variable. You don't see the exponent because an exponent of 1, we typically just write with the variable. Anytime you see a variable without an exponent, you're forced to assume that the exponent is 1. So this would just be 1. There's nothing to add it to. It's just the one variable. Here I've got 1/2 ab squared. A, just like x in the previous one, has its own exponent of 1. So if a has an exponent of 1 and b has an exponent of 2, I do 1 plus 2, the sum equals 3. So this has a degree of 3. And the last one, again, the negative in front doesn't matter. This can be negative. This doesn't matter. But it's m to the 5th power. That term has a power of 5, so it's going to have a degree of 5. Now let's look at some things that break the rules that you should not see in a polynomial. So again, these are terms, but monomial is a specific kind of term. The first two actually have the same reason they don't work. If you remember the first vocab I was looking at, I shared that 2 over n is the same as 2 times n to the -1. That's our negative exponent property. So these first two both have the same reason. I'm going to give a slightly different wording, but I'm going to say no variables in denominators. Which is similar to saying no variables with negative powers. The last one here, I have a variable in the exponent. No variables in the exponent. This is an exponential term, which we learned all about in chapter 6. Exponential terms do not belong as parts of polynomials. Polynomials have special rules and things we can do with them, and some of those special rules fall apart and no longer work if we break certain rules. So some of those rules are having these negative powers, or having a variable in the exponent, an exponential term. So we would not consider these things monomials, even though they are terms. It's a term, but it's not the special term that we would call a monomial. First actual examples for us to work through. 5x squared. Find the degree of this term, this monomial. Well, it's got a power of 2, so degree is 2. I gotta get another better marker over here. Maybe the pink will work nice. Oh yeah, that's bright. Degree equals 2. This next one, I have an x and a y. The x doesn't have an exponent, but it does. It's a 1. We just don't see it. So here I would do 1 plus 3. My degree is going to be 4. This term, I've got x cubed, y cubed. That's going to be 3 plus 3, the sum of the powers again. So degree of 6. And negative 3, that doesn't have a variable. So there's no powers on variables, which means it's just empty. This is just a degree of 2. Or sorry, degree of 0. I don't know why I'm saying 2. Degree of 0. No variable, no power, degree of 0. All right, so now is when you should try the problems at the bottom of the page, identifying the degrees of the monomials. So pause this video and check it again when you're ready. Here are the answers for the try problems. If you got any of these wrong, ask one of your peers or rewind the video and see if you can find what you might have done a mistaken thought process on. Bunch of vocab on this page. It'll come together pretty quick once I do an example, so I'll just read through this. A polynomial can be one monomial or a sum of monomials. So when we see something like 2x squared plus 3x minus 5, this is a polynomial, and each of these is one monomial, one term of the polynomial. The degree of a polynomial is the highest degree of any one term. So if I look at my polynomial up here, I have a degree of 2, a degree of 1, and a degree of 0. So I don't have a degree of 3 for the whole thing. I have a degree of 2. It's just the single highest one. So the degree for my example is just 2. Standard form, which mine's already written in, goes from highest power to lowest, highest degree term to lowest degree term, 2, 1, 0. Sometimes we call that descending order. Start big, end small. And then the lead coefficient, a lot of times I'll write as LC, is the coefficient of the first term when it's written in standard form. So the coefficient of the highest degree term. So my lead coefficient is 2, because my coefficient for my first term is 2. All right, so let's look at some more examples where we actually have to rearrange. Our goal is to rewrite this in standard form, identify its degree, its lead coefficient, and classify it by number of terms. We haven't talked about this yet, but it's a pretty simple idea. So what I'm going to do is I'm going to underline each of these and identify its degree. so I know which one goes first. Now the minus sign in front of the x cubed means that's a negative term. When I rearrange this, the minus stays in front of the x cubed. 15x is a positive term. Negative x cubed is a negative term. You tell by the symbol in front of it. So rewriting this as negative x cubed plus 15x plus 3. So this is standard form. Now it's easy to tell what my degree is. It was the single highest degree. My degree is 3 from the x cubed term. My lead coefficient is the coefficient of my first term. So that'd be the number right here. Can you tell that that's a -1? There's just a negative sign, but if we need to pretend there's a number in front of a variable where there is no number, it's always a 1. So my lead coefficient is -1. Now to classify it, there's 4 names. One term is monomial, so that's not ours. Mono means one term. 2 terms, also not ours. That's a binomial, like a bicycle, so binomial. 3 terms is our last one with a special name, so this is going to be ours. Here we got a tricycle, 3 wheels, except trinomial. So again, that word tri means 3. So we are a trinomial. 4 or more will always have the same name, then it's just a polynomial. We stop giving them special names once they're bigger than 3. So this is the solution to our problem. Those are all of the pieces of information we need to share. All right, so it's a bunch of vocabulary. We're not doing any calculating or algorithm stuff right now. We're just getting comfortable with our vocab. A few more examples just so I can talk through this a bit more. So we're going to do the same 4 pieces of information. This is already in standard form, so I'm just going to rewrite it. Standard form. It's only one term, so it has to be the biggest power, right? Well, what is its degree? It's a monomial, so whatever its power is has to be the degree of the whole thing. Its lead coefficient, again, it's the only term. I only have one thing to look at. The number in front is a -3. And its classification, it's one term. So what's our one term name? That is a monomial. Next problem, standard form. I do have to rearrange this one. Let's look at the terms. I've got an x squared, that's the biggest. Then I've got an x minus x. And then 4 is going to be the smallest, so plus 4 at the end. 2, 1, 0. So my degree is just 2, whatever my biggest term was. So my degree is 2. My lead coefficient is the number in front of that term, so 5. And my classification, this one has 3 terms. 3 is trinomial. My last problem over here, standard form again first. This is a degree of 5 and 1, so the degree of 5 goes first. That makes my degree of the whole polynomial 5. There's no number in front of the q, so my lead coefficient is going to be our default number of 1. Classify it again, it's 2 terms. 2 is binomial. The next few problems are try it yourself problems, so this would be another good time to pause and try those before you resume the video. Here are my answers. Check your work against mine. Again, if you got anything different than me, go back and see what you might have, just noticed a mistake. My lead coefficient here should be, oh wait, no, that's right. Sorry, I was looking up here instead of right here. Yeah, no, we're all good. So check yours against mine, go back and look at the notes if you messed anything up. This next part of the note should definitely be review. It's just combining like terms. All right, so let's organize our information here. It might help you to think, especially when we get to the next set of problems where we're subtracting, finding the difference. What's in front of the parentheses? If you don't see anything, it's just a 1. And what would distributing 1 do? Multiplying by 1 doesn't change anything. So if there's nothing in front of your parentheses, not even a minus sign, then you basically can just remove the parentheses and the problem will be the same. So really this equation is just 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. We'll pretend I distributed a 1. Nothing changes. So what I do now is I identify like terms, 2x cubed and x cubed, and then I add the numbers in front. So we need the same variable part, including exponent, and then we add the coefficients. So we need to check and see if terms are negative or positive terms. So here it's a 2x cubed plus a 1x cubed. 2 plus 1 is 3. That gives me 3x cubed. Next, I'll do my x squareds. Negative 5x squared, positive 2x squared. Negative 5 plus 2 is negative 3. So I'm going to do minus 3x squared. Then I've got an x. There's no other plain x, so there's nothing to combine with, so it's just plus x again. And then there's minus 1. There's no other plain constants, so I just do minus 1. So this is my answer in standard form. All right. Now, these symbols I'm using are just to organize information. All right, I'm grouping things with a little bit of different notes. So I've got a curvy underline, and then I've got a flat underline, boxes, circles. It's just a way to organize information. Another way you can do this is after you've used something, you can cross it out so you have less to look at. Once you've found all of its like terms, it won't get reused. So as we go, we could be crossing out our work, and it leaves less for us to look at. There's a couple of ways to organize your work here, but the main idea is combine like terms. We'll do one more example with adding, and then we'll do some difference. This problem, there's once again nothing to distribute. There's nothing in front of the parentheses. So the parentheses don't need to be here. Now I'll try and do it in standard form again. I'll start with my highest degree terms, the x squareds. I've got a 3x squared and a 1x squared. 3 plus 1 is 4. So I have 4x squareds. That term's done. I'll cross it out. Now I've got an x and a 4x. 1 plus 4 is 5, so plus 5x. Those terms are done. I'll cross them out so I have less to look at. Now I've got a minus 6 and a plus 10. Negative 6 plus 10 is positive 4. So I've got a plus 4, and I'm out of terms. So everything has been accounted for. This is my standard form answer. Because I did it highest to lowest, it ended up in standard form by default. All right. For finding the difference, this minus sign is something that has to get distributed. This first parentheses has nothing in front of it, but the second parentheses has a negative 1. That negative needs to make its way into every term. Basically, I'm subtracting the whole parentheses, not just one part of it. So everything in here will end up opposite of what it was. So I'll rewrite what my equation is going to look like. So now it'll be a positive 2n squared, a minus 2n, and a plus 4. Now it's back to normal. Now I can look for matching terms. 4n squared, 2n squared, 4 plus 2 is 6. So I have 6n squareds. Those are done. Now I've got minus 2n. That's the only n term, so it doesn't combine with anything else. Then I've got plus 5 and plus 4. 5 plus 4 is 9, so that combines to plus 9. Standard form solution. We'll do one more difference problem. But when we see this minus sign, we do have to distribute the negative to each of the terms in the parentheses. Once again, nothing in front of the first parentheses, so the parentheses don't need to be there. But I have to distribute this negative 1. So I end up with 4x squared minus 3x plus 5. That part didn't change, but now it's minus 3x squared plus x and plus 8. So start with my x squared terms. 4x squared and minus 3x squared. 4 plus negative 3 is 1. 1x squared. Those are done for. Now I've got minus 3x plus x. Negative 3 plus 1 is negative 2. So negative 2x minus 2x. Those are done. Then my plain numbers, I've got a plus 5 and a plus 8. 5 plus 8 is 13. And there's our difference. The next few are just 4 more for you to try. I don't tell you whether it's the sum or difference, but you should be able to figure it out. So why don't you try those 4 on the back page real quick, check your answers, and that's it for the 7.1 notes. Check your answers one more time. If something wasn't right, check your work back over and compare with people around you too. All right. Hopefully things went smooth. Make sure you email me or keep track of any questions you have from the lesson.